Well, hello and welcome to another one of my thoughts videos. In this one I'm quite excited because I was wrong, well, not terribly wrong, concerning photosynthesis. Not so much wrong in that I have adjusted my learning or got a little bit deeper meaning for that, because this has implications for all those other things, alternative energies in the body and the fourth state water and all those sorts of things. It turns out that my understanding of photosynthesis was pretty good. That's where the sun comes in to the chlorophyll and excites the chlorophyll, and it breaks the water molecule apart. That's the hydrogens and all the protein ions and the oxygen. Now, up until now, I thought that the energized chlorophyll was adding electrons to the water and then separating off the proteins or the hydrogens from the oxygen. It turns out it's exactly the opposite. After studying it a bit further, there is a manganese valence, they call it, a manganese molecule which has 25 protons, neutrons and electrons, so it's fairly powerful, so that when the photons come in and hit it, it energizes, I believe it's the protons within the nucleus, that they get stronger, the pull on them becomes more energetic, and therefore it then robs or removes electrons from the water. That means it has to be at least 3 or 4 because it has to take the one from the hydrogen or the protium and the other hydrogen protium and one from the oxygen at least, because the byproduct is that the oxygen becomes deprived of at least 1 electron, so that 2 oxygens have to then migrate together and share electrons and spaces, and it makes the O2, the 2 oxygens. Now those protiums, which are hydrogen, ionized hydrogen, they are now without an electron. They just, and this is where a lot of confusion is coming in. I think I've said in another video, they're calling them protons, when in actual fact they're not protons. They're a hydrogen type of hydrogen, because there's 3 types of hydrogen. This one's called a protium because it has 1 electron and 1 proton. And the fact that it loses the electron does not mean that it's a proton. It just means it's an ionized hydrogen or ionized protium. It's called a protium because a real hydrogen has 2 electrons, but that's a, yeah, we won't get into that. Anyway, it's a proton. Because this has great implications. Turns out in hydrolysis, where they're trying to split water by putting electricity into the water and breaking them apart into the hydrogen, the protiums and the oxygens, in actual fact they are adding electrons and doing what I thought was happening in the photosynthesis situation. By adding 1, it fills the gap, and then the hydrogen comes off and turns into a real hydrogen with 2 electrons and with 1 proton in its center and no neutron, and the oxygen, or it can fill up oxygens and make that a little bit better, so you're getting those addition of electrons. This means that the hydrolysis process of supposedly wanting to get energy from water is not true in this case. In hydrolysis, you are adding, it becomes a battery. The water, by splitting it, is saving electrons, which you then get back once the water combines together in combustion, and you are using the water as a storage medium, a battery. But in photosynthesis, and that goes with also with your hair and your freckles and your retina and all those types of photosynthesis, and in the plant photosynthesis as well, is that you are taking electrons away. So in that case you are taking energy from the water, but in hydrolysis you are adding to it and turning it into a battery basically. So this has implications. Now, when that photon comes in and hits the manganese, it makes it more powerful because it's got more protons, I think, and the cumulative effect is that it will then be like a big magnet, which is much stronger than the smaller hydrogen magnet, and it will then just suck one off because that proton on its own is not able to hold that electron, whereas those protons, the magnetic pull from 25 protons in the center of the manganese is able to suck those electrons off momentarily until it loses that energy, and then it goes back to its normal state, and then those electrons come off, aren't held with that that magnetic pull, and then it gets passed on to other chemicals in the chain of events in the photosynthesis chain. There's a number of them. I'm yet to study all of those in more detail as to which ones they are. It will be interesting to see how many protons and neutrons they have in their nucleus, to see how strong that pull is when it becomes energized, and then it accepts and then passes along the chain until those electrons are used elsewhere. However, as a summary, that is my correction on photosynthesis. If you can follow me here, it would be nice to do diagrams and everything. I'm going to have to scrap the other one because it's now out of date, and it means that it has great implications as far as the mitochondria, the fourth state of water, and how that affects it. And I also suspect that the current thinking on the Krebs cycle and the ATP synthase cycle of making ATP to run that motor, I think they're wrong. So in another video I'll attack that. But in this, just to round up on this one, in photosynthesis those electrons are taken away from the water, breaking the proteins off, and then the oxygen has to find another one to join to that to become stable again, and that's why you get O2 as a byproduct of photosynthesis, and then the hydrogens, the proteins, are then combined with other things and stored. I think the proteins have a lot more importance than they're placing on it thus far. So stay tuned. There's a correction. I was wrong on that. Now there's the correction, and it get back to you on another video.